Welcome to this tutorial. In this video, I'll be sharing on how to present data on a stem and leaf display and how to calculate the mean, standard deviation range, and the quartiles using the sample size given. Okay? So to begin with, let me read the question. This is under the subject business statistics and quantitative methods. So the question reads, the commissions in dollars earned by a sample of 18 insurance brokers in 1 month were as follows. So these are the commissions earned in dollars: 78, 50, 65, 79, 54, and so forth. All right. The examiner asks to say required, present the data above on a stem and leaf display. So on a stem and leaf display, the first thing that we need to do is to identify the smallest figure of all the numbers as we are developing the stem and leaf. So let's look at the smallest number in this figure, in this data given from the sample size. Okay, so we have so far I've seen 40, 45 being the smallest here, 45 being the smallest. There, the 45, and the highest number which I've seen is 102. The 102 here. Okay, so now with this, I know to say my data will range from 40s to 100s. All right, so 40s will be represented by 4, 50s will be represented by 5, 60s will be represented by 6, and 70s by 7, 80s by 8, 90s by 9, and 100s by 10. All right, let me indicate properly how this will look like. Okay, so let me do it in Excel so that you see the way it's going to appear. Okay. It will be easier for me to do it here in Excel. There you go. All right. So like discussed, I have the side which will say stem, and then the other side will say leaf. So what it is I'm going to draw a line like that. That's the first line that I'm drawing. Then I'm drawing another line which will be vertical. Okay, so this line, I need it to come like that. All right. So I'll have that again. This side, I'll call it the stem. And this other side, I'll call it the leaf. So I have the leaf here. Okay, so 40s will be represented by 4s. Then I need the 5, 6, 7, 8, 9, And finally, the tens will be represented by, the hundreds will be represented by 10. Okay, the numbers are too small. Let me just enlarge them a bit. Okay, so now there I go. And then I'll put what we call as the key here. Key is simply to tell us what it means when we see something like, yeah, let me do this. Key tells us what it means when we see something like 5 here, and then 6 the other side. This simply means 56. So this is our key. It is important to indicate the key to the examiner so that the examiner knows what you imply. But however, the examiner is already ahead of us. They already know these things. So either ways you can indicate or you can leave it like that. So now my first number is 78. 78 is here. So I'll write the 8 here, meaning 7 and 8 there, they give me 78. My second number is 50. Okay. 50 is under 5. So I'll just put 0 there, meaning 5 and 0 there gives us 50. My third number is 65. 65, I'll put the 5 here. My fourth number is 79. I'll put a 9 here. So that 7 there and a 9 here indicates 79. The following number is 54. 54 here, I'll put a 4. The next number is 80. Where there is 8, I'll put a 0 there. The next number is 102. 102, where there is a 10 there, I'll put a 2. That means 102. My next number is 45. 45, where there is 4 there, I'll put a 5. My next number is 75. I'll put a 5 where there is 7 there. My next number is 98. Where there is 9, I'll put a 8. My next number is 86. Where there is 8, I'll put a 6 here. My next number is 92. Where there is a 9, I'll put a 2 here. My next number is 69. Where there is a 6, I'll put a 9 there. My next number is 72. Where there is a 7, I'll put a 2 there. My next number is 75. Where there is a 7 again, I'll put a 5. My next number is 80. Where there is an 8, I will put a 0 there. My next number is 97. Where there is a 9, I'll put a 7 there. My next number is 66. Where there is 6 there, I'll put a 6 here. Okay. Now, is this the final result for stem and leaf? Certainly no. I need to rearrange them in order. I need to rearrange them in order. So now instead I'll have my key this side. that the rearranged stem and leaf can come at the bottom there. Again, I'll need that line. And another line this side. I'll indicate again stem, and then this side leaf. Okay. I'm copying the same information, but this time around, I'm arranging it in chronological, or what we call ascending order. Okay. I know from there it's the 4, 5, 6, 7, 8, 9, and 10. So here under the 4s, we only have 5 there to indicate 45. And then under the 5s, there is 0 there. They're already in order, and 4. Under the 6 here, it will be 5, followed by 6, and then 9. So 5, followed by 6, and then 9. That's the ascending order. Under the 7s, we've got 2, 5, 5, 2, 5, 5, 8, 9. Under the 8, we've got 2 zeros, 0, 0, and 6 there. Under the 9s, we've got 8, 2. No, we've got 2, followed by 7, and then 8 in order. Under the 10s, we only have got 1, 1, 0, 2. So now this qualifies to be my stem and leaf plot. Let me just pick it from here and paste it on my solution here. And paste it on my solution here. So that's a display of the stem and leaf. Let me then say solution A. Solution A. I guess there is no issue with doing the stem and leaf. It's clear. And then quickly find the mean. The mean, I had already indicated the formula for the mean. The mean is summation of x over n, which is the number of elements. Summation x over n, which is the number of elements. Now, if you can look at this this data here, starting from 78 and ending at 66, I went ahead of you. I've already found the total of x from 78 to 66, adding them is giving me 1,363. So I've already calculated that. So I assume in your exam, you need to calculate that manually. 1363. 1, 363, 1363. Divide by 18. There are 18 elements. What do I get there as my mean? 1363 divided by 18. I'm getting 75.72 rounded off to decimal places. 75.72. Okay, that is my mean. And then the examiner also requested me to calculate the standard deviation. So standard deviation is basically the square root of variance, and variance is calculated by that formula, which is n multiplied by summation x squared minus open bracket summation of x in the brackets, and then you square it. You see the difference between summation x squared and the summation of x in the brackets, and then you square it. Okay, so let's run through the numbers quickly. Let's run through the numbers quickly. We see what we have. Okay, n is 18, the number of elements, and then this we shall multiply it by summation of x squared. Just likewise, I also did the sum of the x squared. X squared is basically 78. You square it, it gives you that. 50, you square it, it gives you that. And then you add the total. So the summation came to 107,619. That's the summation of x squared. 107,619. 107,619. I close the brackets there. And then I say minus summation of x. Summation of x we established to be 1,363. And then this we square it. That's the difference between summation x squared. Summation x squared is the total of the individual x's which has been squared. Summation of x in brackets and then square, we get the total of x and then we square it. So the totals, like I said, I have already done here. There's x and x squared there. Then I have the totals there. Then n is 18. And then n minus 1, which is 18 minus 1, which gives us 17. So 18 minus 1, sorry. Okay. Then I can process the top part the way I'm seeing it without having any difficulties. 18 multiplied by 107,619, close brackets. So I started with open brackets, 18 multiplied by 107,619, minus open brackets, 1,363, close brackets, and then we square it. So the top part, I'm getting 79,373. Divide by 18 multiplied by 1 minus the 18 minus the 1, which is 17. 18 multiplied by 17 there. I have 306 here. 306 there. I have 79,373 divided by 306, and then I have 259.39 rounded off to 2 decimal places. That's my variance. So I haven't yet gotten my standard deviation. To get my standard deviation, I need to square root this variance. And so square root symbol, where are you? Quickly. Okay, you are there. So 259.39. So square root of 259.39 gives me what? 259.39 The square root of that gives me 16.11 as my standard deviation. All right, so this was easy as long as you master the formula here, which is not really a difficult formula to master. And then I have here the range, which is the highest value. The highest value is basically at the bottom of the stem and leaf. The highest value, we say 10 and 2, that gives us 102. So the highest value is 102 and the lowest value is 45. So 102 minus 45. 102 minus 45. Okay. 102 minus 45, that gives me 57 as my range. And the final thing that I need to do is to get the interquartile range. So I'll need quartile 3. Quartile 3 is placed at a position where we say 1 divided by 3, 1 divided by 1 divided by 4, sorry. It's a quartile 3, no, not 1. 3 divided by 4, it's quartile 3. 3 divided by 4 there, multiply by n plus 1. That's the formula for calculating quartile 3. So n is 18. Not for calculating quartile 3, for calculating the position of quartile 3. So 18 plus 1, that's 19. 19 multiplied by 3. Divide by 4. 14.25. So the 14th value, 14.25. So literally when we round off, that's 14th value. So the 14th value, let's count from the stem and leaf. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th value, here we are seeing 6, but literally this is not 6 because in front of it there is 8. So it's 86. 86 is the Q3, quartile 3. 86. Okay. Quartile 1, in the same manner we did with quartile 3. But this time around, quartile 1, which is that one, will be given by 1 over 4 instead of 3 over 4. 1 over 4, 18 plus 1. So 18 plus 1, that's 19. 19 multiplied by 1 is 19 again. And then divide by 4. We have 4.75 value rounded off. This will be the 5th value. Literally 5th value. So 5th value here, and here I should have said literally 4th value. After rounding off, 4th value. So I'm going to check what the 5th value is. Of course, I know it's not 86. The 5th value is not 86. I know. I'm going to check what the fifth value is. The fifth value is 1, 2, 3, 4, 5, 66. 66 is our Q1. 66 is our Q1. So now with these numbers, I can calculate my interquartile range by simply saying quartile 3, which is 86, minus 66, which is quartile 1. So 86 minus 66 is giving me 20. So the interquartile range for this distribution or data given is basically 20. So this marks the end of the tutorial. Thank you for watching this video. If you found the video helpful, please subscribe to my YouTube channel.